Hi everyone, we are going to go through a 202 quiz review. So the topics on the 202 quiz are order of operations, you will see variables, the distributive property, greatest common factor, and factoring. So first, let's start with our order of operations. Remember that order of operations is what we use when we are simplifying or when we are evaluating expressions. It is a specific order in which we do our operations, so addition, subtraction, multiplication, or division, and it's a set rule, so that way everybody in the world can do it the same. And the acronym that you have maybe heard for this is PIMDOS. Please excuse my dear Aunt Sally. If And this little acronym is helpful because it allows us to remember the steps. A couple notes on our acronym is when we get to the M and the D, so the multiplication and division, and the A and the S, the addition and subtraction, those steps need to be performed in order from left to right. So it's not necessarily that you do all of the multiplication and the division. These are together, and you do any multiplication or division and you just work your way left to right. And then same for the addition and subtraction. You do any addition or subtraction and you go left to right. The other little note I want to make is sometimes you will see instead of a P for parentheses, you'll actually see this as a G for grouping symbol, because that's really what the P for parentheses means, is it means any group of things. And a lot of times we use parentheses as our grouping symbol. But you'll see in these two examples that we have here, there will also be grouping symbols of absolute value and a grouping symbol of a fraction bar. So really GIMDOS, or if you just want to remember the parentheses really means grouping symbol, that's more accurate because it's any parentheses, any group of things together. All right, off my little soapbox there about the G over the P. Let's go ahead and go to question number 1. So we want to evaluate this expression. When you look at it, it may be a little overwhelming because there's a lot of numbers, you see a fraction, you see a decimal, there's a lot of stuff going on. So that's where if we just work through the order of operations one by one, you have your paper and pencil to follow along and do the work on there, you will be okay. Because if you try to do it all in your head, it's probably too much. So definitely when you get to these lengthy order of operations one, use paper and pencil. So the first thing we want to look for is, are there any grouping symbols? And yes, I see two sets. I see grouping symbols being used as parentheses, and I see this grouping symbol of absolute value signs. So we're going to simplify both of those first. I'm just going to bring my 1/2 down because that's not being used at all. Now within this first group here, we're going to continue to follow order of operations. So within the first group, I see that I have an exponent, E for exponents. We're going to do that first. 14 squared means 14 times 14, sorry. 4 squared means 4 times itself 2 times. So 4 times 4 is 16. And then I'm going to bring everything else down. I'm going to make my absolute value signs nice and lengthy, so I know that they're absolute value signs and not like the number 1. Now we're going to continue to simplify within this group here, within these parentheses. We have 16 plus 4, which gives us 20. All right, so that grouping symbol is done. Now we need to do our second one, which is the absolute value bars. So we first need to complete our subtraction. I'll come off to the side here to do that. So we have 8 6/10 minus 3 4/10. Remember to line up your decimal points. 6 minus 4 is 2. Bring your decimal point straight down. 8 minus 3 is 5. So we have the absolute value of 5 2/10. Now we're going to go ahead and take that absolute value. Remember, absolute value is the distance from 0. And because it is distance, whenever you take the absolute value of a number other than 0, it will always be the positive version, because when we're talking about distance, it is always positive. We have 1/2 times 20 plus, and then the absolute value of 5 2/10 is simply 5 2/10. All right, we had to do a lot of work there, but that's okay. We got our grouping symbols all taken care of. Check. Now that the grouping symbols are done, do I have any more exponents? Nope, so I can skip that. Now multiplication and division, that I do see. I have multiplication here, 1/2 times 20. When we multiply fractions, remember that we multiply straight across. But I see a problem here. This 20 isn't a fraction. We can rewrite any number as a fraction by putting it over 1. And then we'll just multiply straight across. 1 times 20 is 20. 2 times 1 is 2. Let's keep simplifying that fraction, because remember, fractions are another way to represent division. So we have 20 over 2, otherwise known as 20 divided by 2, which is 10. So 10 plus 5 2/10. We got that multiplication and division step done. And that leaves us with our final step of addition and subtraction. So 10 plus 5 2/10 is 15 2/10 is our final answer. So it did take, several steps, but it was lots of things that just all smushed together in one. So if you follow the order of operations, if you write down all of your work, I know you can do it. All right, let's do one more example together. Number 2, we are being asked to evaluate this. So let's go ahead and clear this drawing up here so we can have a fresh start with our order of operations. All right, the first thing we want to look for is any parentheses or any other grouping symbols. And I have lots of grouping symbols again. I see this grouping symbol of parentheses. Within that, I see this grouping symbol of an absolute value bar, and I see this grouping symbol of a fraction bar. So when you have lots of them going on, you just work from the inside out. So my innermost grouping symbol is my absolute value bars. So that is what I'm going to work on first. So we have 15 plus, so inside those absolute value bars, we have 2 minus 3, which means 2 minus 3 is -1. Now that we've completed and there's only one thing inside the absolute value bar, we can take the absolute value to finish that portion of our grouping symbol. So the absolute value of -1 is just a +1 because it is 1 unit away from 0. That is its distance away from 0. Leaving us with 15 plus 1 squared all over 4. So now we're going to continue to work on those grouping symbols. And our grouping symbol next is the parentheses. So let's continue to simplify what's inside of there, which would be 15 plus 1, giving us 16 squared over 4. All right. Now we have an exponent, E for exponent. We need to take 16 squared. Remember, 16 squared is 16 times itself 2 times. So 16 times 16, which is 256. So we have 256 over 4. Now we need to see if there's any multiplication or division. I have some division, and in this case, the division is using that fraction bar. So it's 256 divided by 4. This is one that we might need to do longhand. I'm going to come over here to do that. So we have 256 divided by 4. How many times can 4 go into 2? 0. So now I see how many times 4 can go into 25. It can go 6 times. 6 times 4 is 24. And we're left with 1. Bring down your 6. How many times can 4 go into 16? It can go 4 times. And that is done evenly, giving us our final answer of 64. Once again, several steps, but if you follow the order of operations, use your paper, you'll be good. All right, before we get into our next portion, I want to briefly talk about variables, because for the rest of the video, you're going to see variables in the questions. So what is a variable? A variable is any symbol that's used to represent an unknown value. So it's some value that we don't know what it is. Typically, now that we're in 7th grade and moving on for the rest of your math career, we often just use letters. So when people say, why are there letters in math, or what are these letters? They're technically called a variable, and they're just like a placeholder. They're representing a value that is unknown. We don't know, does this represent the number 1? Does it represent the number -20? Does it represent the number 50? It's an unknown value. Now, this kind of, can throw people for a loop, but let me tell you something. You've actually been using variables since elementary school. Just in elementary school, the symbols, that your teacher decided to use, were often either blanks, or maybe they used boxes. So you've always been working with variables. You've always been working with unknown values. We just used to write it a little bit differently. Let me show you what I mean by that. So here, if we look on the left, in elementary school, your teacher would do variables. They would represent unknown values in typically one of these ways. They'd just put a blank, and you'd have to figure out what the unknown value is, what goes in that blank. Or maybe they do a little box, or sometimes even just simply a question mark. Those are all symbols. Those are all variables. But now that they're used more often in 7th grade on, so now that we're here in middle school, the variables that we use are going to be letters. They could be any letter, but the most common ones are going to be X, Y, and Z. So instead of 5 plus blank equals 10, it's 5 plus X equals 10. So 5 plus something is equal to 10. And then 20 divided by Y equals 2. 20 divided by something equals 2. And then 3Z, and remember that means multiplication. When you have a number and a variable side by side smushed together like that, that means they're being multiplied. So 3 times something equals 18. So hopefully that helps you feel a little bit better. You still may or may not like them, but it's not completely foreign. And all it really is just a blank line. It's just a blank space saying this is an unknown value. We don't know what value, what number is represented here. All right, now that we understand what variables are, let's get into the distributive property. So in question 3 here, we are asked to simplify. Well, whenever we see simplify, whenever we see evaluate, our brain should go to order of operations. We need to follow that. We need to either use PEMDAS or GIMDAS, whichever phrase you like, to simplify. And I'll write it both ways. So if we look at number 3 here, we do in fact have a group of things. I see parentheses are being used as my grouping symbol. And I have 2x minus 20. That means 2 times something minus 20. Can I actually simplify what's inside of those? No, that variable gets in the way a little bit because I don't know it's 2 times something equals 20. I don't know what that something is. Therefore, I can't really subtract 20 from it. Another way to look at it is they're not like terms. When we're working with adding and subtracting only, things have to be alike in order for us to add or subtract them. They both don't have variables, and so therefore they're not alike. I cannot do that subtraction. That is where the distributive property comes in to the rescue, because the distributive property allows us to still complete this order of operations step, just we can do it a little bit differently. When we're not able to actually do the addition or subtraction inside the grouping symbol, we can use the distributive property instead. And the distributive property tells us that we're going to distribute, aka we're going to multiply. So if we look at our problem here, we have a -3 right outside the parentheses. Because parentheses, they're like a double agent. They are used both as a grouping symbol, and parentheses can be used to represent multiplication. That 3 is being multiplied by 2x minus 20. So if we wanted to write it differently, we could put a little, oof, that's an ugly 3. We could put a little dot there to help us see that 3 is being multiplied by this group of things. So therefore, we can distribute, we can multiply that 3 to everything within the parentheses to get rid of our parentheses, to get rid of our grouping symbol. We can take -3 and multiply that by 2x. When we have a regular number, like -3, and we're multiplying it by a number and a variable, so 2x, we just multiply the number portion as normal. So -3 times 2 is -6. And then this x continues along for the ride, because technically he is being multiplied as well. So it's really -3 times 2 times x. So we multiplied the portion we can work with. -3 times 2 is -6. And then that's being multiplied by x, that unknown value. When you distribute, that -3 is outside of the entire parentheses. So that means that -3 is going to be multiplied by everything within inside the parentheses. So we're going to bring down our subtraction sign, and then we're going to take -3 times -20. What would be -3 times -20? That would be a +60. All right, in order of operations, we got that done. Don't have any exponents. There's no multiplication that I can do because the only multiplication is -6 times x, and I don't know what x is. There's no subtraction that I can do because I'm trying to subtract from a variable and I don't know what that variable is. So we're actually done. A lot of times when you simplify and when you use the distributive property, at least in this grade level, that will be it. That is our simplified answer. There's nothing else that we can do to it because we don't know the value of x. All right, that one was a lengthy explanation. Let's do number 4 a little bit quicker. So number 4 here, I'm being told to simplify. I see that I have a grouping symbol. I have those parentheses, but once I look inside, I can't really do anything in there. I have 1/3 y plus 1/7. They are not like terms. because the 1/3 has a y, the 1/7 doesn't. So because they're not alike, I can't really add them together, which means I'm going to use that distributive property because I notice there's a 2 right outside the parentheses, and that 2 is being multiplied by the parentheses. So we're going to multiply, we're going to distribute. So we're first going to take 2 times 1/3 y. Remember, when we're multiplying with fractions, you can turn any number when you're doing anything with fractions, you can turn any number into a fraction by putting it over 1. And then when we go to multiply, we just go straight across. So 2 times 1 is 2, 1 times 3 is 3, and that's still just being multiplied by y. We'll just bring it on down because we don't know what y is. It's that unknown value. That's what a variable is an unknown value. And then we'll take 2 times 1/7. Don't forget to bring down your plus sign. So let's turn that 2 into a fraction again. 2 times 1 is 2. 1 times 7 is 7. And when I look at this, I'm all done. I distributed, so I got rid of that grouping symbol. There's no exponents, and there's no multiplication or addition that I'm able to do because these guys aren't alike. 2/3 has a variable, 2/7 doesn't. So we're finished. All right, before we get into factoring, let's quickly review GCF because we're going to need to use this to help us factor. So remember, in previous years, you've worked with greatest common factors. The 2 most common ways to show your work are either listing out your factors horizontally or doing a factor tree. I'll do a factor tree and then I'll organize it horizontally so you guys can see both. So if we want to know the greatest common factor between 8 and 12, we first need to identify what the factors are of each. So factors, remember, are 2 numbers that are multiplied together to get that product, to get that answer. So if I do a factor tree to begin with, for 8, I'm going to list all of my factor pairs, all of the numbers that multiply together to get 8. I just like to work in order to make sure I don't miss anything. So we have 1 times 8 is 8. Then let's go to 2. 2 times what is 8? 2 times 4. How about 3? Is 3 times anything 8? Nope. And then I'm back to 4, which I've already used. So those are my factors of 8. And then if I list them out here horizontally, I have 1, 2, 4, and 8. Now let's list our factors of 12. So we have 1 times 12. And then 2 times 6 is 12, and 3 times 4 is 12, and I'm at 3 and 4, which means there's nothing left. So if I list them out in order, 1, 2, 3, 4, 6, and 12. Now that I know my factors of each, I need to look and see what is the greatest one that they have in common. That'll be our GCF. So they don't have a 12 in common, they don't have a 6, they don't have an 8, but looky here, they have a 4 in common. So the GCF between 8 and 12 is 4. Now that we've reviewed GCFs, we're going to use those greatest common factors to complete factoring. Factoring is actually the opposite of the distributive property. So if we think about the distributive property, remember, I'm going to just say DP, distributive property. To perform the distributive property, we had to multiply. Oh wait, that's not a P. Good grief. Mrs. Ailstock, what are you doing here? There we go. When we did the distributive property a moment ago, the way that we distributed was we multiplied. Well, if factoring's the opposite of that, The opposite of multiplication is division. So in order for us to factor something, we are going to end up dividing. So if we look at 6 here, we are being told to factor 18y plus 6. Our first step is we need to identify what we're factoring by. We need to identify our GCF, the greatest common factor. So I'm going to list out my factors for my two numbers, 18 and 6. So we have 1 and 18, 2 times 9 is 18, 3 times 6 is 18, 4 doesn't go into 18, neither does 5, which brings me back to 6, so I'm done. Those are my factors of 18. Now for my factors of 6, 1 times 6, 2 times 3, and that's it. So what would be our GCF? What do they have in common? The greatest one they have in common is 3. Now that we've identified our GCF, we can divide that out. That is how we factor. So I'm going to rewrite my original expression here, 18y plus 6, and we're going to factor out, meaning we are going to divide both of these numbers by our greatest common factor. When we write our answer, we always write it in this format. We have our GCF first, and then after we do that division, that answer is going to go inside parentheses. We have 18y divided by 3. We can just divide our numbers, and then because the y is being multiplied, it'll just continue and carry along. So 18 divided by 3 is 6, and we bring the y with it. Bring down your plus sign. 6 divided by 3 is 2, and we close our parentheses, and this right here is the factored form. We have now factored that. We have undone the distributive property. Because if you look at your answer, that's like what we used to distribute. So that's why your answer looks like that, because they're opposites. All right, let's look at 7 here. Actually, I'm going to change up 7 real quick, and we're going to make it multiple choice so we can show you some test-taking strategies on that. All right, here's something cool about these factoring problems. Because we know that factoring and distributive property are opposites of each other, if you're, say, better at factoring or better at distributive property and you get a multiple choice question, an awesome test-taking strategy is kind of working backwards. So if we're asked to factor this and we see that we have 3 choices here, and you are like, oof, there's a decimal there, I'm not really sure what a common factor is. I'm not sure what I can divide both 4.4 and 2 by. You could look at your answer choices and try to get and basically work backwards. So we look at our answer choices here, and I could use the distributive property, because that's the opposite of factoring, to try to get my original question. So if I take 4 times 4.1y, that would give me 4.4y, and then 4 times -2, or a -2, would be 8. Nope, that doesn't match. Wrong answer. So now I could go, and again, I could choose the backward strategy where you work backwards if it's multiple choice. So we're going to distribute 2 times 2.2y would be 4.4y, and then 2 times 2 would be 4. Oof, close, but not quite. So let's hope this last one works, but because it's a quiz or a test, I never want to just guess. I want to be sure. So 2 times 2.2y equals 4.4y, and then I realized I'm not doing a good job of showing my work because you got to distribute to everything. So then 2 times 1 is 2, and looky there, that matches, which means that C is the factored form. So factoring and distributive property are opposites of each other that can really help you out. To remember that distributive property is when you're multiplying. Factoring is the opposite of that. It's when you're trying to see what you can divide by instead. And there's a cool little test taking strategy. All right, I hope this video helped you feel more confident in going forth on the 202 quiz. If this is your first attempt, then make sure that you have your notebook handy so you can reference the notes you've taken and also work out the problems by hand. If you are watching this video and you've already taken the quiz and now you're like, oh, I understand what I did wrong, then email your teacher and give them the code word flower, and you will earn another attempt. So once again, if you've already used up your attempt on the 202 quiz, but since watching this video, you understand and you've learned from your mistakes, email your teacher and say, I would like a retake on the 202 quiz. The code word is flower, and another attempt will be unlocked for you. All right, guys, as always, if you have questions, make sure to look at your schedule to attend those small groups and those help sessions so we can work with you, or just shoot us an email. Bye.